Hey, my peeps. Can everybody hear me?
Yeah, we can hear you.
All right. I can hear you too, which is a beautiful thing. Let me just make sure it's coming out of the YouTube thing. All right, I can hear you too. All right, you guys are popping out of YouTube, so that's great. I'd like to note that it's 1:01 p.m. within 1 minute of an on-time departure. That is legendary.
Boss, way to go, Dr. K.
I'm trying, man. I'm rocking it to the best of my ability. Oh, but wait, not quite. No video. Hang on. Duh.
Yeah, we were just waiting for it to go live on Discord.
Well.
Yeah.
You announced your voice and you made it within 101. That's great.
That's not bad. And but it is correct that I did not have my video to you guys yet, which I now have. There we go. All right. There we go. Now we're rocking. Oh man. What are we like week 4 or something absurd?
Yeah. 3, 4.
How did we get here? This seems just crazy to me. 1, 2, 3. We're ending week 4. I don't know. That just seems crazy. I mean, it's good. There's like 16 of these we got to do, so that means we're a quarter of the way there. Now, not all of you are a quarter of a way to completion, but you're getting there. Okay, let me see. I'm pulling up Mr. Slides here. So, number 1, I realized at the end of our Tuesday time that we had actually finished Module 2. Not also crazy, right? Nice. Yeah, shout out to Unit 1. Wait, is that shout out to the people still working on Module 1? Is that what that they're still on Unit 1. Yeah, thank you. That's right. But so those of you that are, can I do my warning? Should I do my Fear of God speech right now? I have a couple of Fear of God speeches, but
Didn't you already email about that? You said something about along those lines of staying on Unit 1, you're way behind or something like that.
Yeah, exactly. Thanks for the summary. Yes.
That was my fear right there. Oh my gosh.
Yeah, no, right. And that's part of the reason we have the due dates turning on, right? So I did turn on the due date for Module 2 because I didn't say anything in lecture time, but I realized as soon as we wrapped up and I was just kind of looking at it, and I was like, oh my gosh, we actually finished Module 2 because that's all the content that's in Module 2. So if you are still on Module 1, you got to move like a racehorse and wrap it up. The good news is Module 1, if you look at the homework, right, it's like, let's talk about ambiguity and natural languages and a little bit about abstraction and the fish story, right? That's Module 1. It's really kind of high-level conceptual. Fair? Is that fair? Everybody that's finished Module 1? It's not crazy.
Yeah, it's not that bad.
And you do have to practice on the module exam using your words, saying words, and, giving a little bit of a full answer and explaining things. So that's just a reminder again. It's the short answer questions on the module exam are inviting you to explain stuff and not inviting you to just drop a couple buzzwords on us. Cool. I'm just actually getting my slides ready to rock and roll because we're talking about math, arithmetic operations. There we go. But yeah, if you are still on module 1, you've got to make your move. You got to make your move, right? Just like those horses on the GIF on the chat. You got to make your move. And yeah, I also want to just say the meme of the day, that is a little dated, but it still feels like that sometimes. You know what I mean? The meme, to me, it's there. You know what I mean? There's still a lot of lockdown-ish feeling, you know what I mean, to what we're living through. So I just like to remind myself and us that we're kind of still all in that together, and just understand that one of the reasons that I try to be available at odd hours and just whenever I'm on Discord you can grab me, is the fact that when we don't have that regular go to sit, I mean, thank goodness, I hate those chairs they make you sit in, and you know, there's a lot about that I really don't miss, but there is still a physical and emotional cost to the more isolated way of living right now that we're still kind of in. So I try to just remind myself that we're still in that, and I'm available as stuff happens. You know what I mean? Hit me up. I don't even care if you just want to chat about something else. Seriously, like whatever. I don't even care. I've got a couple threads going with students already on a number of really cool topics. And it's just conversation, just conversational thread, go explore a topic, whatever it happens to be. So, or join the School of Rock server, which I think I gave you an invite for that already. But I'll drop another one because we need some people in the School of Rock that can actually make some things happen over here. Because right now it's pretty dead. So I just dropped the invite for School of Rock. That's just for trying to make some music, you know, on the side and do a little remote music, or if you just want to talk about music, which I'm always game to talk about. Okay, how we doing? This is a small crowd. We got a small crowd on the voice chat today, it seems. I'm not sure. But
hey, Dr. K?
Yeah, man.
Is the due date supposed to have been changed on Module 2 yet, or is that...
Should have been. Did I not do that? Did it? Hey.
It doesn't look like that's the case right now.
Hey, Zach. Zach, you're on here, right? Zach Penrod.
Zach's dead.
Please come to a white courtesy phone.
Oh no.
All right, you there? Yeah, we're talking about you, Zach. Hey, would you mind jumping over and making sure that Module 2 has a deadline of a week from Tuesday? So that'd be the 22nd. I bet I only turned one of them on. I bet I only changed the deadline on like one of those, and I didn't do all of them. I think it was pilot error on my part.
Yeah, knowing you. I'll go check it.
Yeah, thanks, man. And then, drop back and give us a report if you wouldn't mind. Just, interrupt after you've checked it. But let's get that taken care of. Okay. All right. Anything else? Thanks for the heads up on that. That was the intent to get that cooked. One other thing to just keep in mind about the way these things pace. If you look at the schedule, it kind of goes a little slow for the first few modules, and the reason is because we're introducing this brand new, for a lot of you, maybe for most of you, really kind of a brand new idea about binary, just the whole base 2 binary, whatever. It's all really foundational. It's going to speed up, but just understand that the modules at the end, when it's like suddenly we'll be doing like a module a week, or there might even be times we'll do like a module in one day, but it's going to be a much, much smaller module, okay? So don't be deceived by that. And then also, I think I've said this before, but when we calculate the grades, I calculate them 2 ways. One is where every module carries the same weight as every other module, okay? And then it's like a percentage per module of that 7%, I guess it is. The other way that I calculate it is where there's an aggregate. So like module 2 and module 3, I think have some large points on the exam because there's a lot of little parts. And so they kind of are bigger magnitude. So the other way I do it is I aggregate everything, all the points, into one grand mass and sort of look at your percentage of that. I calculate it both ways. I take the highest one. Okay, so, and I think that Canvas is I don't know which way Canvas is calculating it. Zach, that's your second to-do item. Figure out which way Canvas is calculating that. I think it's per modules all being equal. Not sure.
The due dates, so
What's that? What's that, Zach?
they're updated on Canvas.
Already?
I've been notified. Yeah.
So you're saying there was no pilot error on my part. But then whoever had the comment
I
earlier?
updated them just now.
Oh, you updated it. Okay. It hadn't been.
It was your pilot error.
Hang on a second. I didn't want to have to go to incognito mode, but I feel that it's time that I hide my head in shame. Okay, yeah, thanks, Zach. Thanks, man. And then, Zach, can you also, while we're just rolling here, I'm going to jump into the Mr. Lecture slides. Would you mind just double checking which way Canvas does the grade calculation? If it aggregates all the points, or if every module has like a separate its own, the same percent, so that it's aggregation. Sorry, what am I trying to say? Is it an aggregation of all the points, or is it 12 modules of 7% each? I think it's the latter. But would you mind just doing a confirmation on that while we roll?
Sure.
Thanks, man.
No problem. Go check it out.
Alrighty, thanks. Okay, are you? Shall we rock and roll, my friends? Let's do the thing. I say yeah. I say yeah. And then also, again, reminder: testing lobby. We've got hours, staff. The hours are listed on the syllabus. Okay. And so if you want to just like, I really like Zach, or I really like Vlad, or whatever, then you can know when they're on duty. That's in the syllabus on Canvas. Okay.
Team Zach.
Team Zach. Woo. So yeah, and then but at any other odd time, if you want to just like drop a question, if any of us see that and we've got a minute, we can jump on. You know what I mean? Even if it's not during scheduled times. And we're really, really happy to jump on. As long as we're available, we're really, really happy to do that. Okay. Any other housekeeping that I wanted to say? I don't think so. If you have any problems, please, please, please hit us up. Okay. Okay, so we have talked about binary, base 2, addition, different notations, right? Sign magnitude, 2's complement, unsigned. We didn't really do slides that said unsigned, but just understand that there is this idea that it's just a positive number from 0 to, let me just ask you that. If I've got 8 bits and it's unsigned, which means we don't even have to worry about representing negative numbers at all, then what's our range? 0 clearly is the smallest. What's the biggest?
6. No, it's not 6.
I'm
It was
coming.
a joke.
I'm
It was
coming
a joke,
through.
Dr. K.
I'm coming through the camera. I can't take it anymore. No, what? Now, what's the grand total? What's the biggest number? Come on.
1.
No. You got 8 bits, not 1 bit.
Oh.
If it were 1 bit, sure. But 8
Okay.
bits.
I thought you meant with 1 symbol.
No, 8 bits. What's the biggest number? Unsigned. I'm just going to wait. I got all day.
15.
255.
Thank you. 255. That's it. It's all the bits are on. So I've got a 1, a 2, a 4, an 8, a 16, a 32, a 64, and a 128. When we were in kind of sign magnitude mode, we only had the 7 bits, that were kind of the magnitude. So you could go from negative 128 up to positive 127. But basically it's 127, which is the biggest positive number if you have a sign to fiddle around, right? It'll be 0. Actually, I'm going to do it this way. That's your direction, right? Yes, sorry. I was going, being the self-centered guy that I am, I was doing it from my perspective. This is your perspective, right? So you got the 0, and the rest is 127. If I don't have to worry about sign, that guy can just be data value. He's worth 128. What's 128 plus 127? 255. That's it. Anyway, yeah, so that's unsigned, and that's a real thing, okay? There's a lot of unsigned integers out there. But now we're going to talk about two things immediately. We should get through these today, maybe, I think. And that is, the first is arithmetic, the mathy stuff, and the second is what we call bitwise operations, okay? So let's rock and roll on arithmetic. So this is doing mathy stuff, addition, subtraction, and there are other operations, right? Obviously, multiplication, division, square root, etc., right? There's all these other math functions, but it all really starts with addition and subtraction. And the truth is, once you can do addition and negation, you can actually build everything else. Isn't that weird? Doesn't that seem a little crazy? But if I have addition and negation, I can do everything. I can build it all up from there. That's weird, but true. So there's a couple of ideas that are really critical that we're going to talk about, okay? One of them is sign extension or sign extending, and the other one is overflow. And I'm just going to, that's kind of bookmarking those so you know where we're going. And all we're really going to worry about for now really is addition and subtraction. Just understand, if you remember your math in, I don't know when you learned this crap, junior high, something, I don't know. You know, what's multiplication? It's just adding something a bunch of times, right? What's division? You know what I mean? It's kind of subtracting stuff and with certain kind of rules. And then once I've got multiplication and division and addition and subtraction, I've got building blocks to do with, you know, moving toward a square root, you know what I mean, and other kinds of stuff. But, and then addition, super clean, you got that now, right? Everyone's got that? And then I realized too, some of these are like really slow pitch. I get it. So I appreciate you sort of like indulging me a little bit when I asked the really dumb slow pitch question, right? Just because I'd rather have you say it because I just feel like, I don't know, I get tired of saying it. So everybody knows how to do addition by this point. Real quick, somebody, how do we do subtraction? 2 steps. What do we do? Anybody?
Negate the second number, then add them together.
That's it. We negate the second one. The one that we're subtracting, right? X minus Y. Whatever Y is, we negate it and we add it. That's it. That's subtraction, okay? Boom. Easy peasy, right? Now, what about, let's just take a look at this right now. Cool addition trick. Adding a number to itself, right? Everyone cool with that, right? You go, where's my mouse? There we go. You go, right? 1 plus 1 is 0, right? You got 1, 1, 1 that gives you 1, carry the 1. The 1 drops down. 1 and 1 is 0, no carry. Sorry, a carry. Sorry. 1, 0, 0, that's 1. 1 and 1 is 0, carry the 1, right? You can just look at that and validate. Yes, 43 plus 43 is 86, okay? What do you notice about this number 43 and this number 86? Anybody? Bueller?
You just shifted the bits over to the left.
Yeah, exactly. Just think about that for a second. Okay? That's it. I mean, all of those just went over 1, and then we added a spare 0. Thank you for the... oh my gosh, what's that actor's name? I love him. Ben Steen? Somebody look up that name on that guy. I think it's Ben Steen or Ben Stern. I'm dropping the teacher in Ferris Bueller. and a bunch of other things. Okay, where's the intuition? Anybody got an insight into the intuition of that? You know, I mean, you see it.
Yeah.
That's literally 43.
So I don't want to say it.
No, but nobody knows who's talking. That's the thing. It's, Ben Stein. I was wrong. I had 2 guesses and got them wrong both times, but I was dang close. No, go ahead, Chris. It's all good because it's kind of it's sort of more. Nobody knows who's talking anyway. What's the intuition? Because it's like there's 43, and then just this 0 tacked on. Like, what the heck? Why is that a thing?
Well,
Go ahead. Yeah, go ahead, Andrew.
if we're thinking about like base 10, if you times something by 10, it just shifts it over and adds a 0.
Right?
This
Right.
is base 2. So you times by 2, it's over.
Yeah, it's the base. It's the base, right? Because in whatever the base is, base 2, base 3, 8, 12, 16, doesn't matter, 10, right? Every one is a power. Every one. So when you multiply something by 10, you just tack a 0 on, right? So if I go, here's a nice decimal. We'll call that a decimal number, right? 123. And if I tack the 0 on, I just multiplied by 10 because I took the one that was formerly in the 1 spot, and now that's in the 10 spot. Formerly in the 10 spot, he's now in the 100 spot. Formerly in the 100 spot's now in the 1,000 spot. And when I just shoved everybody over, they all just bumped up 1 level of power. I was in the 10 to the 0 spot. I'm now in the 10 to the 1 spot, right? Well, binary, exactly the same thing. Okay, here's a nice binary number, right? Which is 5 in decimal, right? And if I just go, check it out. That's 5 in decimal. I tack on a 0, and then, sorry, I want that to dry out. I tack on a 0. Isn't this great? This is like the whiteboard. It's fantastic. I tack on a 0, so this guy gets promoted from being a 1s to being a 2s. And then this guy gets promoted from being a 2 to being a 4, or not. Sorry, you can't see it. And then this guy gets promoted from having been, 1, 2, 4, from having been a 4 to being an 8 now. So I've now got 8 plus 2, which is 10, right? So in other words, in binary, I can multiply by 2 just by shifting left 1 bit and just shoving a 0 in.
Figured out how the grade works.
Oh, thanks, Zach. Go for it.
So it's a sum of all the points divided by the total amount of points attempted slash how many the due dates.
Okay, all right. So it is all aggregated.
Yeah, it's multiplied by 100, so it's a percentage, and then the final grade, I guess, takes the percentage of each assignment group and multiplies it by its weight.
Of which is 84%, right, on this one.
So like if you got 100%
Okay.
on the exams assignment group, it would be 100% times 84 plus the large program would be like 100 times 16.
Right. But it does mean, okay, thank you. So it does mean that if you were to smoke a one of the exams that has a lot of points, it is actually valued more in the final grade than another module with fewer points.
Yes, that's how it works.
Now, right, and then just thanks, Zach. I appreciate that. And then the way I'm calculating it is that way plus the other way where just every module gets 7%. So when you get one that's only got like 15 points on the module exam, that's also 7%. So you can help yourself by not neglecting, the smaller modules, the smaller topics. And whichever way works to your advantage is the way I'm going to roll on that. Because that's how we roll in the land of Dr. K. All right, so that's so it turns out that a lot of math, when you start to do like arithmetic, multiplication, whatever, in binary, or when you're working at kind of like the low machine level, and you're building like the multiplication instruction, one of the things that it'll actually do is look for things like, is there any power of 2 in this multiplication, right? Like I'm going to multiply some value by 40, right? Well, okay, so 40 is, let's see, that's 8 times 5, right? It's 2 times 2. If you break it down, it's 2 times 2 times 2 times 5. Isn't that right? Did I get that right? 2 times 2 is 4, times 2 is 8, times 5 is 40, right? So if I'm writing a little math module and I can see that number, I can factor it, and I can take the three twos, and instead of looping 40 times to add it, I just start by just shifting the value, for you guys, right? I just start by shifting the value 3 bits and tacking on zeros. Boom, just multiplied by 8. Now I can loop that 5 times. You see how much faster that would be? As opposed to doing the same addition 80 times, 40 times. So this becomes a trick that actually shows up a lot when you're down in the grunge and trying to be efficient. Cool. And then Zach just posted to the chat on Discord the formula for the way that that Canvas is calculating the grade. That just helps you to be a little more on top of, managing to all of that. Yeah. Okay, let's keep going. Let's rockin' and rollin'. How do you multiply? Yeah, this is actually, we really already talked about this. How do you multiply a decimal number by 10? You just shove it over. We did that already. Binary number by 2, same thing. We kind of already walked through it. You shove it over, tack on a 0. Okay, now, here's the thing. Sign extension. This is a really, really important concept. It's a tiny concept. Tiny. But it's really an important concept, okay? When we're doing decimal, we don't care, right? If I just give you a math problem, we usually don't worry about leading zeros. I mean, that if I tell you, if I give you a value like, 73 decimal, and then I just go, oh, I meant 0073, that the math doesn't change, right? You don't care. But when we're dealing in binary and we're dealing in kind of machine architecture and assembly language and machine code, the challenge is that we're dealing with a fixed number of bits. When we're doing math out in the real world and I say, okay, I got a math problem for you, 5,723,000,000, you just write it all down and you just do it. Or you plug it into your calculator and you don't worry about it. But in binary, you have to know, okay, this is an 8-bit integer, or it's a 16-bit integer, or a 32-bit integer, but I've got to know how much space I've got. Remember we talked about last time a little bit about overflow, right? How you'd have to know, somebody made the insight that I thought was great, that you'd have to know how big it is to know whether there's overflow. And when we do normal math in decimal, we don't really think about overflow, right? Because there's no conceptual limit. You just keep adding and carrying out to the left, and you just get more paper or more whiteboard or whatever. You don't care. Computers, you're stuck because there's a limitation to the space you've got. So leading zeros, we don't care. So for example, if I take something like this binary number, right, which is anybody want a quick translation to decimal? Eleven, right. We got a 1, no 2s, we got a 4, and we got an 8. No, is that right? No, it's not 11. 13, isn't it? Yeah, it's 13. So I've got 1 plus no 2s plus a 3, that's 4, plus a 3, that's 4. Look, I'm a friggin' idiot. Hold tight. Plus a 4. A 1 plus a 4 plus an 8. That's 13. Am I right that time? It's easy to make the dumb, it's easy to sort of get lost. That's 13, right? Yeah. No. Sorry. My problem? I'm reading it backwards in my camera. I'm reading it mirror image. Hang on. I'm going to go like this so I'm looking at it correctly. I got an 8, I got no 4s. I got a 2 and I got a 1. 11. Sorry, everybody. For everybody that was like trying to track with me, who dared to believe Dr. K in that moment, I got to be more cautious with binary when I'm reading it, that way. Okay, so that's 11. If I'm going to do some math with this, I got to go, and I've got 8-bit integers, I've got to go leading zeros, right? I have to pad it. I got to pad it in order to do the math. Because the way, and we're going to talk later on about like adders, we'll call a thing that we call a full adder, where you've got 8 bits here, and then there's another 8 bits, and the circuitry is kind of going to go bing to bing, it's going to go 0 plus 0 or 1 plus 1 or whatever, you know what I mean? And, right, and it's got to have the 8 bits. So to do the math on this thing, if I'm going to do an addition, I have to pad it out to 8 bits, okay? And in fact, I padded it wrong because I need, what's funny is I have a whiteboard behind me, but it's too far away. I'm going to start this over. Can we start over? I'm going to start over. Let's take this number, which is probably, it's 4, all right? And I'm going to do, thank you for the reset button. Oh, man, it's been just tough. I pad with zeros, and now I can do the math for whatever the next thing is. But here's the problem. Let's go back to the one that I just scrubbed, which was 1011, which, as we've established, beyond a shadow of a doubt, is 11, okay? That guy there, what is it actually? If I give you this number, and I say, it's just these 4 bits, and the number is 2's complement. I was kind of living in unsigned integer land there for a second. But if I say that's a 2's complement number, what's that actual number? It's not 11, if it's 2's complement notation.
Negative.
Yeah, so I've got a...
No.
I got an echo coming from somebody. I have to flip all the bits, right? And add 1 to find out what the magnitude is, which gives me -5. Okay? So that number there is -5. Everybody tracking? If I take -5 and I pad it with zeros, what's that number? What's this number now?
Positive.
It's
Positive 11.
Yeah, it's 11.
Oh, well, cool.
Yeah, it's that same number, right? But it's all of a sudden it's positive 11. We took -5, and if we just pad it with zeros, all of a sudden it's positive 11. That's not even right. That's not the right number. If I add 11 to the previous one up here, which was 4, it's going to be all screwed up. So how do I make that number, pad out to 8 bits, but stay -5?
Move the 1 all the way to the end.
I pad the 1 I don't move it.
Yeah,
I don't move it.
We'll pad the 1.
Pad it, yeah. So I start with this guy, and then I just I pad with 1s instead of zeros. Now this is a little bit of a slight little mind bender, right? Because you're like, whoa, that just feels weird. Okay? But that is still -5. So when you've got a negative number, right, and the leftmost right there, that leftmost bit was a 1, and you got to pad with 1s. Here's the intuition. Let's do it. I'm going to turn it this way. The intuition is, what's that number? Well, flip all the bits, right? You flipped all the bits. Do you see what just happened? All those trailing 1s turned to trailing zeros as you were converting it to a positive number. Add 1, and you got, boom, +5. We already know it's a negative number, so we wrote the minus sign down, right? But the positive magnitude is 5. You everyone see it? Everyone got it? Is that burned into your head? Oh, yeah. That's the trick. You've got to remember it, though, because if you screw it up, doom. If it's a negative number, you got to pad. You got to pad with ones. That's the bottom line. And again, the intuition is when you go to flip it to become a positive number, all those ones go to zeros. Boom, leading zeros. We're back in comfort land, right? We're back where we're comfortable. That's it. If you have questions as we go, please stop me. Otherwise, I'm going to keep on rocking and rolling. Okay. As you play around with this a little bit, you'll see it. But here's the key: when you're on the module exams, like Module 2, there are some questions where I'm just going to give you, some binary numbers and some other binary numbers. I'm not going to tell you about any notation. If I don't tell you notation, it's unsigned. If I don't say it's something different, default is they're just bits. It's just unsigned. And there's no concept of negative with just, normal binary digits. If I say it's 2's complement, then it's 2's complement notation. If I say it's unsigned or sign magnitude or, if I state something, but if I don't state anything, it's just unsigned. That's your default, okay? So if I just give you a question like this, if I give you a question like that, and I just say, here are 2 binary numbers, and I don't say anything else about it, then you're just doing binary math on a piece of paper, And you just add them, and your answer is just more binary, and you just presume it's unsigned because you didn't say anything, right? Social contract. Where's my social contract? Where's that social contract? It's about the social contract. If I don't say what it is that's different, default is these are just binary numbers. Just like if I told you, if I gave you this problem, 73 plus 10, if I gave you that problem, you would just add them up and not worry about it. It's the same thing, okay? So be super careful with that when it's exam time. What else? Yeah. But you're going to get more comfortable with that over time. Now, let's talk about overflow. And we talked a little bit about it, but I know that a bunch of you are bugged by it, right? You're like, wait, ignore the carry? How can that even make sense? Dr. K, surely you are a charlatan and a fraud teaching us this crap. I got 8 bits, and then my answer requires more than 8, and you're just okay with that. Right? Anyone had this thought? I mean, maybe not that I'm a charlatan, or maybe, yes, that I am a charlatan, but just this thought of the intuition doesn't even make sense, right? You add 2 8-bit numbers and you get a 9-bit result and you're okay with that? Anybody besides me? That always has bugged me.
That you can't add the 2 numbers.
What's that?
If you get that, doesn't it mean that the number is out of bounds and you can't add it?
No, that's the thing. That doesn't mean that. Okay? It doesn't mean that.
That upsets.
And that's just really, really bizarre. Okay? So this is the thing. You got to wrestle a little bit. By the way, the unfortunate thing I realize is that the GIFs, they don't animate unless I bring Discord to my to the focus. So I see when behind my OBS when Discord's back there, and I can see the comments. I have to highlight it to get the animation, which is unfortunate and sad. But they're really good. I appreciate your contributions in the land of GIF. Here's the deal. I don't even know how much intuition there really is here. But when you're dealing... Well, okay, first of all, let me be really clear about something. If you are in unsigned land, okay, you have unsigned integers, and you've got the 8, and you add them to 8, and they spill out, that is overflow if you're unsigned. Everyone's cool with that, right? If everybody's unsigned, you've got to fit, or you can't hold on to the answer. It's too big. So that intuition is fine. Everything just changes though when you get to 2's complement. Okay? That's the crazy part. That 2's complement, when you've got 2's complement numbers, binary numbers represented in 2's complement notation, then you don't care about the carry out. What you do care about is the carry into the sign bit. That's what you care about, is the carry into the sign bit. Because if you overflow out of these 7, remember that's kind of your magnitude. These 7 bits are your magnitude. That guy is just the sign. So when you overflow out of the magnitude and you get a bigger number that wants to spill in here and fiddle with the sign, that's when you're screwed up. And the way it manifests itself is that you take 2 positive numbers. And I think we're going to do this. Let me just double check. Yeah, we're going to do it. You take 2 positive numbers, and if you add them and the answer's negative, do you see it? You had to have overflowed into the sign bit. You messed with the sign, right? Or you give me 2 negative numbers, right? You got 2 negative numbers, you add them together, and you get a positive number. What just happened? Overflowed into the sign. So there is overflow, but it's not when it kicks all the way out. That's like some of the weird magic of 2's complement that we don't care about the overflow or the carry all the way out. Okay? But we do care about a screw up when it carries into the sign bit. Just trying to find, a little bit of intuition. But at least you can just remember that, okay, if it's unsigned, there's no sign. It's purely magnitude. You give me 8 bits plus 8 bits, and the answer is 9, that's overflow. But if it's 2's complement notation, you've only got 7 bits of magnitude and a sign bit, right? So if you have 2 positive numbers and you add them and you get a negative, that's overflow. 2 negative numbers and you add them and you get a positive, that's overflow. When you're dealing with 2's complement arithmetic. All right? Everybody cool with that? So you can think of it, you can either try to find the intuition as a way to help you remember that, or you can just rote memorize it. This is how you do overflow in 2's complement. This is what you look like when you're doing rote memorization, right? Certainly what it feels like. I'm typically a bigger fan of trying to find the intuition. So when I'm in the moment, I can almost figure it out in the moment. You know what I mean? Because if I memorize it, maybe I'll get it wrong. You know what I mean? Maybe that's just how my brain works. But okay, let's do some examples. Let's take this one. If I've got so understand that we are in the world of 2's complement notation now, okay? These numbers are in 2's complement notation. And this one is positive 83. It turns out to be positive 83 irrespective of the notation, right? But we're saying it's 2's complement. And here's another positive 83. I start to run the numbers on that, right? I start to add them up, and I think I'm just going to kind of walk through it. 1 and 1, we should have a 0 carry the 1. 1 carry the 1. The 1 just drops down. 0, 1. Sorry. 0 carry the 1. Then we get a 1 here. That's going to be a 0 carry the 1. And do you see how the sign bit's going to change? So that's what we just walked through. That's what I just said, but written. So I just added positive 83 plus positive 83, and what did I get? Not positive 80. For starters, I got a negative number. It doesn't even matter what it is, but I think we can find out. It's negative 90. If you take that number and flip all the bits and add 1, you're going to get 90. So that value is negative 90. You had, hey, everybody, what's 83 plus 83? Negative 90. Puh. No. You took 2 positive numbers, you added them together, and you got a negative number. This is not right. So that's overflow. That's overflow. Now, another way to sort of intuit this is, look, the maximum positive value with 8 bits in 2's complement notation is 127, right, over here? A 0 with all 1s. It's 127, as we kind of walked through before. What's 83 plus 83? Just decimal. 166. So you can already see that we're going to get an answer that's too big to hang on to it. But when it spills out and gets dumb, it's just going to screw up the sign bit. That's it. And then the part where in 2's complement we don't actually care about the carry out, that's just magic. I don't know what that is. All right.
So
Yeah, go.
overflow is okay as long as the sign bit still matches?
No. Overflow by definition is bad.
Okay.
So, in other words, if I'm doing regular 2's complement arithmetic and there's a carry out that we ignore, that's not overflow. That's just a carry out that we ignore. Yeah. By definition, it's not overflow because the number is still fine. Okay? So what about 2 negatives? Answer, of course, it's exactly the same thing. If I don't have a slide for it, but if we did negative 83 plus negative 83, it's going to be the same problem. The answer is negative 166, and the largest negative number we can represent in 2's complement is negative 128. We already know, we can look at it and go, that answer is going to be too big. We can't hold it. Now, if we had, so Isaac, explain, you said, would it be the same for any 2 negative numbers? Just explain what you mean by the same. Do you mean is the rule the same, that if you add any 2 negative numbers and you get a positive, it's overflow? Yes. If that's what you meant by that, then the answer is yes. But definitely clarify, okay? Let's see. All right. Are there any questions about this? There's a few noodling things. Yeah, exactly, Isaac. Thank you. Are there any questions that are bugging you, nagging you at this point? Thank you for...
I was wondering, does the overflow still occur in unsigned?
Yeah, and I kind of mentioned it, but I don't have a slide. And I need to add a slide, really, truly, about unsigned overflow. Zach, would you just punch me in the face or something until I actually do that? I'm making a note.
You want me to punch you?
In the face, yes. Repeatedly until a certain behavior manifests itself, which would be that I add a slide to this set to talk about unsigned overflow. Because I really short it. I really do short it, I think.
Yeah, you
but
were talking about last semester.
did I say last semester that I needed to add a slide?
No, you did have a slide.
No. You made that up in your head. So here's an example.
Talk about it on a whiteboard.
We probably whiteboarded it. I'm sure it's...
We whiteboarded it.
Yeah, that's part of the struggle. That's part of the struggle with doing the online thing. Because I would regularly, as Zach can attest, when we were in person, I would just jump on the whiteboard whenever the mood, would strike. But here's just an example. If I'm going to give a super easy example. We're unsigned. I'm even going to write it. Okay, this is an unsigned number, and it's 8-bit, right? It's the maximum unsigned number, 255. And then I just decide to add to it, I just add that. Oops, hang on. Where are we? Problem is, once I show it, I can't see it. Right? We add that. What's the answer going to be? You can do that in your head just looking at it.
256.
The answer is going to be 256, and in particular, it's going to be 1 over here on the left. It's going to be, the answer is going to be 9 bits is the point, right? Because what's going to happen is we're going to go 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 0, carry the 1. 0, carry the 1. 0, carry the 1. All the way to here where we go to carry the 1. And the answer, if it's unsigned, the answer is 256. But the biggest number we can represent in 8 bits unsigned is 255. So that we can intuit that the number is too big, but put another way, we took 2 8-bit numbers, we added them, and when we were done, it didn't fit in the 8 bits. So that's overflow. Now you could try to capture it. You could try to, you know what I mean? You could have 16-bit answers, and if anything flows out, you're okay. You hang on to it, or you know what I mean? Or just, if you can tell it's going to be overflow, you just double the size of your integers or whatever. But, you know, it depends on a lot of dynamics. But basically, if I say I've got an 8-bit adder, that's in hardware. And if I add them up and I kick out, you know, it's overflow. Let me see. The trick with adding a number to itself. Oh, Jacob, the trick of adding a number to itself work with negative numbers. I don't even know. Hang on a second. Let's do it. Let's do it real quick, okay? This is again where I would whiteboard if we had whiteboard. But is this working?
Mostly.
Mostly, right? It's just, it's kind of, the lighting's a little funk. Like I said, I do have a whiteboard, but it's like way over there. I need like, I don't know, a second camera where I can jump to the whiteboard. But no, let's do the thing. Let's go with this 2's complement number. Okay? It's 2's complement. So that number, if we convert it, we get 0, 1, 0, 1. We add 1, we get 0, 1, 1, 0, which is equal to, so that's negative 6. Okay? So this value is negative 6. Right? If we double it, we want to get negative 12. And let's take a look at what negative 12 should be, which is going to be, we'll take positive 12, which is, we got an 8 and a 4 and a 0. 0. Nah, I'm blowing it. The number's too big. We get overflow. I need a better example. Something that actually still fits. Because if I've got a 4-bit 2's complement number, the largest value is 3 bits of magnitude, which is only positive 7 and negative 8. Foiled. Okay, let's try a different number. Let's try negative 3. How about? Negative 3, which is going to be 0, 0, 1, 1, is the positive version. To make the negative version, we flip it. We add 1. So we get, that is negative 3. Cool? We all good? When I double it, I want to get negative 12. Sorry. I was looking at the other one. I want to get negative 6, which is I want to get, where's negative 6? It's going to be 0, 1, 1, 0 is positive 6. We add 1. So it's going to be, okay, sorry, this is now turning into like, you know, I'm talking technology. So that's what we're trying to go for and see if we get it. 1, 0, 1, 0, that's negative 6. So what happens here? What happens if we add a 0 and slide everything left? What's really weird, I don't even know. I think we're heading off into weird territory. What actually happens if I do that and I ignore everything, purge whatever's happening right now from your heads. Because weirdly, if I do that and then I just get rid of that, it actually turns out to be correct. But I don't even know if that's like just a weird artifact of this particular thing or if there's a principle there. I don't even know. So Jacob, I'm bailing on you, okay? I'm bailing on your question because it feels like we're on the highway to the danger zone now. So I don't even know. So Jacob, you go find out, okay? And let us know because I don't know. And then, so David, raised the question of, it would work in decimal. No, not really, because in decimal, you have this minus sign out there, this magic minus sign. You go 352. Or you put a little horizontal line and you go negative 352. You tack on a 0. Oh, negative 3250, 3520. Oh, positive 3520. The negative, it's not the same thing. Because in decimal, you just hang around with this negative sign, and everything else really, truly is kind of just operating unsigned. But you just keep a negative sign around to remind you what it is. It's really a different system. With binary, you're stuck with, I got this many bits, and that's what I got to work with. That's one of the big, big differences. Thank you for the Kenny Loggins video, and thank you for catching my Top Gun reference. That was a great song, by the way, by Kenny Loggins. And thank you for bringing me the Iceman and Maverick. Okay, let me see. Were there any other so Jacob, thanks for stumping. See if you can stump the professor. The other question, so David had the question, does signed overflow work the same way as 2's complement? So work the same way as 2's complement. 2's complement is a notation. I'm gonna call you out, David, okay? 2's complement is a notation, so work the same way. The question doesn't make sense to me. I can't parse it. So I'll let you clarify. And then Goose didn't make it, okay? Goose, I'm sorry, spoiler. Goose had a need for speed. When you add two positives, yes. When you add two positives and get a negative in 2's complement notation. If you add two positives, get a negative, it's overflow. You add two negatives and get a positive, it's overflow. Okay. New Top Gun is going to be awesome. Do you realize that freaking Tom Cruise is I don't know, he's like my age, which is absurd.
But Dr. Gay, so funny thing about that, they actually wanted, I'm sorry, this is off topic. They wanted.
Now throw it, we need it.
So Tom Cruise really wanted to fly in that jet, one of the jets that he was using. And he asked the Air Force multiple times in the new Top Gun if he could fly. He was rejected.
You mean pilot. You do mean pilot.
Actually pilot with somebody. Yes, actually pilot. He was rejected by the Air Force multiple times because they knew, he's short, so he's perfect as a pilot, but he was rejected multiple times because, you never know what's going to happen. So the Air Force is like, no, Tom Cruise, we're not going to let you do that. But right. I think it's pretty cool that he asked. It's pretty cool. A lot of guts.
Yeah, well, and Cruise is a pilot. He is a pilot. I doubt he's whatever they're flying, their F-15s. I don't know what they're flying, but...
not that advanced, but yes, yeah.
Yeah, exactly. No, I love it.
He also actually hung out the side of a plane in one of the Mission Impossible movies.
Yeah, no, exactly. That was Rogue Nation. That was literally, if you watch it, we were off topic, but
Burj Khalifa.
And he was in fact on the outside of the Burj Khalifa. I've been to the top, not to the top, but I've been to the observation platform on the Burj Khalifa. But Cruise was literally in which whenever that was. Was that the same one?
Maybe.
I can't remember. It's one of those. It might be Rogue Nation. It might be whatever. But no, he really did climb on the outside of the Burj Khalifa. Those stunts where he's on the little thing and he's doing the thing. Truly. And if you've ever been up on that bad boy, holy crap. And then, there's the other one where the plane takes off and he's on the outside. And he's going, Benji, open the door.
Yeah.
And, that's really him. And he's really on the outside of an actual plane taking off. And they had to build, we're way off topic. It's okay. Skip forward five.
We're going into the danger zone right now.
We are in the danger zone. I started this. Okay. But they actually built special contacts for him that covered his entire eye. Basically like goggle contacts.
Oh, really?
Yeah, because he was going frickin' fast. So he had contacts that actually protected his eyes that were full size, and they had to do that take 4 or 5 times.
What? That is insane. Wow.
Go off, and he's flying there. So he's flying there on the outside of the plane, and then they just CGI erased he was cabled on, pretty securely, of course, but they then CGI the cabling off.
He gets his power from Scientology.
Maybe.
Crazy Scientologist I know.
He is the most powerful Scientologist I know of.
He's actually one of the leading contributors, to Scientology.
Of course, right. So yeah. Now that's way off topic. Once we start going into religion, we're way off topic.
It is anyway. We're going in the danger zone.
We'll pull out of the danger zone. But man, so now I just looked it up. Cruz is 2 years younger than me. He's a freak, man. He's a freaking freak.
Yeah.
No, he's actually he's 2.5 years younger than me.
Wow.
Amazing. Yeah, anyway, I love Tom Cruise. Anyway, I'm an unabashed man crush on Tom Cruise as an actor. I just got to say it. So, all right, we're bringing it back. How are we going to bring it back? Boom, with a new transition to a new topic. That's how we bring it back. Yeah, so Caleb, I think that was directed at me. Yeah, my fandom of Tom Cruise as an actor has absolutely nothing to do with his life belief system. Absolutely irrelevant to me. I'm not marrying the guy, you know what I mean? Then I would have to probably make some deeper...
But you kind of want to.
No, if I were gay, oh yeah, absolutely. Well, I don't know if I want to marry him. If I were gay, I would date him. I'm not. It turns out I'm not, so I don't even know. But I just think he's just an amazing action act. We're way far afield now. Thank you, Jim. I'd like to go on the record because we're streaming to YouTube. But I just want to go on the record to say that if I were gay and single, no question, I would want to date Tom Cruise. It's not even a question. Marry a different. That feels a little volatile.
All right.
Okay, are we going? Back from the danger zone. You forced a confession out of me. That's not really even a confession. I'm pretty confident about all that. But I do love the guy's movies. Okay, now we just got done doing math. And by the way, Tom, if you see this, it's okay, man. I'm straight. It's not. You don't have to worry about me. I'm not coming after you. Operations on bits. So we talked about math, right? We talked about. Oh man, this is the best 2810 lecture of all time. This is the best.
Yeah, we should try our best. Territory. We got to come back to Maverick territory.
Bring it back to Maverick. I have a need for speed. Okay, logical operators. So we can do mathy stuff, but what about just like bitwise operators? That's a thing, okay? And even though you guys, like in 1400, you touch binary, you touch, base 2 hex, you touch it so briefly. We're obviously drilling really, really deep, right? But it turns out that there are logical operators, and these actually become the basis for what we think of as high-level logical operators. Like if you say, here's some condition, right? Here's an expression. If this expression is true and this other expression is true, then, right, it's a classic condition for an if-then-else, right? That you know of in more high-level programming languages like Python or whatever.
This is exactly what I'm learning along with another student here in my previous class from this one, and or not.
Okay, yeah, right. What's the class? What's the other class, by the way?
Discrete mathematics.
Oh, yeah. Okay, I was gonna say I don't have that.
Okay. Yeah, no, it all weaves together. What we're going to get into is actually the low-level implementation of that idea. Because you're going to talk about De Morgan's law and modus ponens and modus tollens and all the other crap.
That's if our teacher remembers how to teach it.
Exactly.
We're not even going there.
Yeah.
He might even retire by the end of the week, maybe. I don't know.
Yeah, maybe. So, by the way, Zach, I think you might be fired. We have to have a conversation. But Zach, hey everybody, this is Zach's last day.
Bye, Zach.
Zach, it's been great. It's been so great.
I'm you, man.
Oh my gosh. My line for Tom is "You had me at hello." That's my line for Tom. Okay. No, anyway, we're pulling. No more Tom. No more Tom. I do need to rewatch Rogue Nation though now, so there's that. No, so what happens is at the high level, logistically, there's this idea of, not this or this, that kind of thing, the ands and the ors and the nots. Well, it turns out that with very few of these operations, you can build up all the rest of it. And this is, in fact, the fundamental hardware building blocks of the high-level constructions. If x is less than 7, then do this. If it's more than 7, do that. These are, we sometimes refer to them as Boolean operators, right? Meaning they're kind of like true or false. Well, it turns out that we can do all that same stuff in hardware down low. If we were to say something like, let's use 0 and 1. Let's call one of them true and the other one false. What would you pick? One's going to be true. One of these two is going to be true and the other one's going to be false. Which one would you pick? Just out of curiosity.
For 0 and 1?
Yeah. One of them is going to be true. The other one's going to be false.
Well,
they'll represent the idea of true and false.
Well, if you think of on and off, you think of, isn't 0 off and 1 on?
Right? I think that's...
Would 0 be false and 1 be true?
I think that's solid intuition. I think it's solid intuition. And in fact, in some languages like C, I don't know how many languages, but I do know that this is true of C, and I'm pretty sure then of C++. You can do a Boolean operator on any integer, on any value. And if that value is 0, it'll count that as false. And if it's anything non-zero, it'll count it as true. Right? Which is kind of cool. You can just take some counter, set it big, start dropping it every time, -1, right? And if the thing gets to 0, then that's false. Otherwise, it was always true. If you accidentally skip past 0, you got problems because it's going to stay true all the way down. You have to think about things like less than or equal or, other kinds of conditions. But it turns out that you can do all those constructs down in the machine language. And we're going to talk about it. We're going to show you how to do it, which is actually pretty cool. But you just have to not be afraid of it. You know what I mean? That's really the key. So logical operations, or we may think of them as bitwise operations, are operations on the bits themselves. Okay? And these are the ones that we kind of care the most about, and or not, and exclusive or, and we'll break these down, okay? And, anyway, remember social contract? Which I don't know if did I throw social contract out? I may have.
Still have that crumpled paper? Yeah.
Yeah. I think it's down in here somewhere, but it's in my recycle bin. It's all about social contract. If I say this value plus this value, and I do mean addition, and it's like 2's complement, the social contract tells us what the rules are, right? 1 plus 1 is 0, carry the 1, all the rules. When we do bitwise operations, we might have the same thing, only it's like these 8 bits and these 8 bits, but I only look at that 1 bit compared to that 1 bit. That's it. And the answer in that same column is going to be whatever the answer is. And then I just do the next one. But there's no carry bits or stuff like that. It's a bitwise operation, okay? But the result of the operation is either 0 or 1. Always, always, always. There's none of this carry madness. Now, we kind of mentioned these already, but I just want to be really, really clear. In high-level languages, there are both Boolean operators, which are logical, right? If some expression, you write, you know what I mean, alphabetic name is less than L, you write, and individual is a student, or you know what I mean, there's some set of conditions. That's a logical operator that we would think of as a Boolean operation, and when we're done, the answer is either true or false, right? That's Boolean. A bitwise operation would say, here's a set of bits, here's another set of bits, and we're going to AND them together, or we're going to OR them together, and the bits themselves combine to make a new set of bits. That's the answer. You see the difference? The first one, we're just trying to ask the question, you know, if this is true and that's true, then the whole expression is true, and it's all about true, false in a broad way. Bitwise operations, we are literally performing mathy stuff, but with a different set of rules. Okay? And we are focused right now on bitwise operations. Later on, when we start talking about actually writing programs with machine language, what we'll wind up doing is actually something that's much more like Boolean. Okay? Because we'll be saying, you know, is it time to, do we want to draw, it's like an if then else. Do we go in or do we skip around it, right? Same idea. And how are we doing time-wise? We're doing...
Got about 5 minutes.
It's remarkable when I start on time or close to it. I'm getting better at starting on time. Okay. One little interlude that's really important. The word binary, unfortunately, it's kind of an overloaded term. Okay? Now, binary as a term means like one of two options. That's what binary means. Base 2, 0 or 1. There are two possibilities, and it's one of the two. That's binary. Okay? It also refers to any operation that takes two operands. So, I mean, but generically, binary just means two of something. So, binary numbers are numbers that consist of zeros and ones. Base 2, right? That's a binary number. A binary operator is any operator that takes two operands. 5 plus 6, you know, plus is a binary operator. Addition, you know, is a binary operator. A plus B, two of them. Not is a unary operator. It only has one operand, okay? Multiplication, A times B, binary operator. So unfortunately, and I just want to apologize, I want to not only apologize for portions of this lecture, but I also want to apologize for the fact that you all have to suffer through this weird ambiguity of this term binary, because when we talk about a binary operator, it has nothing to do with operators on base 2. So I'm really sorry. I don't know what to do beyond apologizing. Just understand that. Okay? So when I refer to binary operators, two operands, that doesn't have to be binary numbers, could be anything. Okay. Are you ready? We got like 5 minutes. Let's do some goodness here. Zach is still obsessing and concerned. By the way, if anybody's like just watching this on YouTube, you really are missing a lot of the effect by not tracking the comments on Discord. Okay, let's talk about AND. By the way, these are really simple concepts. They're really, really simple concepts. And being in CS, there's a reason why we're hitting it here down in the assembly language and the machine stuff. And then you're also hitting it in like discrete structures. This is really foundational to computer science logic, okay? So, and it is a binary operator, meaning that it takes two variables as operands and has nothing to do, strictly speaking, with binary numbers. But we are talking about binary bitwise functions, okay? Simply put, an AND is true when both variables are true. And otherwise it's false. You know, they have to just both be on. So you can think of them as like they're both true, they're both 1, they're both on. You can use, and I've heard all varieties of that, right? If they're both true, if they're both on, if they're both 1, those are all analogous, okay? Now this little bad boy right here, believe it or not, this is going to sound really corny and cliche, but it's actually called a truth table. Why? I'm not, it's a truth table. Whatever, go figure it out. It involves trues and falses and whatever, but that's what they call
or
it.
that it's verifying truth.
Perhaps, or manifesting and representing the truth of what this stuff means. I don't know. But we do call it a truth table. So this just lays out, just to understand how to read this thing, this you read it across, okay? 0 and 0 is 0. 0 and 1 is 0. 1 and 0 is 0, right? Because the question is, are they both on? No, they're not both on. False. How about down here? Oh, look, they're both on. The answer, true. Also known as on. Also known as 1. And I say those different things because you can do that however you want. You can, if you like to think of it as 1 and 1 is 1, great. If you like to think of it as if they're both on, the answer's true, great. Whatever works for you as you conceptualize it, okay? But that's how a truth table works. And you will have to do the truth tables. You'll have to fill out truth tables. I'll give you like an expression, and then you're going to fill out the truth table. So you'll have an opportunity, okay? So, and I'm going to wrap up on and, because we're like a minute over. And let me just wrap up on this. So, again, this is not addition now. This is not addition. So the question is, look at the column, look at the two numbers. Are they both on? If they are, then on. That's it. So first column, are they both on? Yep. Both on? Nope. 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 Yes, they're both on. Nope. Nope. That's it. This is really easy. Okay? And in fact, you can even go looking and just go, okay, are there zeros anywhere? Oh, there's a 0, so that's going to be a 0. There's a 0. Oh, they're both 1s, that's going to be a 1. A 0, a 0. I'm just looking for zeros. If I see a 0 and you got an AND function, I know it's going to be 0. Right? Order doesn't matter. I don't even know why I have that question there. That seems so obvious. But this is just a reminder. You're doing column-wise compare. Take the two numbers, give me the answer. Put it there. This turns out to be unbelievably valuable and important in doing a crap ton of things in computer science. Okay? So what I'm going to do, we're 2 minutes over now. I started like 2 minutes late. So let's stop here. We're going to come back to OR. On Tuesday, we will finish. Yeah, I think we'll finish. This is module 3. So you better get on your game, get on your horse. Strap yourself to the outside of an airplane. Get the special contacts. You don't want to damage your eyes. Get yourself a pilot's license. All right, that's all I got. I'm gonna stick around for a little while in the testing lobby. I think Vlad shows up around 3. But yeah, stick around if you got any questions. I'm gonna go ahead and stop the stream to YouTube right now.
Thank you very much.
You're welcome. This was good. This is more fun to talk about other stuff, at least as an interlude, you know?
Yeah.
Yeah, otherwise it's just too boring.
Oh, yeah.
That's the problem, so. But nah, you're very